I'm going to solve this system of equations using the addition method, which is also known as the elimination method, because one of your variables is going to eliminate, either the x's or the y's. And if you look right now, the first thing to notice is that these two are not in the same order. So I do need to have my x's stacked up on top, my y's stacked up on top, and my constants stacked up on top. So what I'm going to do is I'm going to put both of these equations into standard form of a line. Okay, so that way I'll have my x's on top of each other, my y's on top of each other, and then my constants on top of each other. So let's get the x's first. If I look at the top equation, the x is on the left, I need to move this 3y. So I'm going to subtract 3y from both sides of the equal sign, and then I'll be left with 2x minus 3y equals 6. All right, now let's look at the bottom equation, and you'll see for this one I need to move this x to the left side. So it's a minus 6x. I will have to add 6x to both sides, and I'll be left with 6x plus 7y equals -3. All right, now at this point, I'm looking to cancel my x's or my y's. If I just added them together right now, my x's will not cancel, my y's will not cancel. I need to change one or both of these equations so that the x's are opposite or the y's are opposite. So when I add them together, they will cancel out. If you look at the x's, and you can choose the x's, the least common multiple between 2x and 6x is 6. So I would need to change this. I need to multiply it times 3. I'd actually need to multiply it times -3. That would give me a -6x. If I wanted to cancel the y's, what's the least common multiple here? 3 and 7. I'd have to go up to 21 on both of the equations. Now I'm actually going to choose to cancel the y's because one of them is already negative and one of them is already positive, and I'm going to make fewer mistakes if I don't have to multiply through by a negative. So I will have to multiply both equations, but I think I can do that. So multiply the top equation. To get this to be a -21y, I need to multiply everything through by 7. Okay, and I have to multiply the entire equation, both sides. And then the bottom equation, to get 21y, I would need to multiply everything through by 3. All right, let's do that. Let's move it over and let's see what it looks like. Okay, my top equation, it is going to be 7 times 2x is 14x. 7 times -3y is -21y. Don't forget the right side. 7 times 6 is 42. My bottom equation, 3 times 6x is going to be 18x. 3 times 7y is going to be plus 21y. And 3 times -3 is going to be -9. And now we're going to add. Okay, addition method. Let's add them. When I add them together, I'm going to notice that the -21y plus 21y is going to turn into a 0, and that's exactly what I want. I'm eliminating that variable. 14x plus 18x is going to be 32x. And then 42 plus a -9 is going to be 33. All right, so I have an equation here that says 32x equals 33, and I can solve this. I'm going to divide both sides by 32, and I get something that is not exactly the nicest looking number, but that's the answer. Okay, it is a number. Normally when I get a strange looking fraction like this, I might want to double check my work, but I just did that and I know that this is the correct answer. So if I know that x is 33 over 2, I can plug that into either one of the original equations, and I will find out what my y is. Now, since this one right here is already solved, kind of solved for y, the y is already on the side by itself, I'm going to plug it into this equation. All right, so I dropped it down, 7y equals negative 3 minus 6x. And instead of x, I'm going to plug in this right here, 33 over 32. So here we go, 33 over 32. All right, now I have 7y equals negative 3. And let me see what 6 times 33 over 32 is. I'm going to get my calculator. 6 times 33 ABC 32 equals, that's going to give me 99 over 16. All right, you may have it as a mixed number, 6 and 3/16, that's fine. Now let's put these two together. Negative 3 minus this number. Negative 3 minus 99 over 16. And that gives me a negative 9 and 3/16. I'm going to put it as an improper fraction. Negative 147 over 16. And then one more step to get my y by itself. Grumpy old y wants to be by herself. We need to divide out this 7. Okay, and now I'm going to get y equals, and then this is a big calculator job for you right here. I have negative 147 over 16 divided by 7, and that is going to give me negative 21 over 16. All right, I got a strange looking fraction for my x value, and I'm not surprised that I get a similar looking fraction for my y value. If I was on a test, I would probably want to double check my work here. Maybe I'd want to work this problem again, but cancel out the x's and see if I get the same thing. But since I was expecting these fractions, I feel pretty confident about this. So the solution set is, it is going to be an ordered pair. It's going to be a point, and the x value goes in front, 33 over 32. And the y value goes after, negative 21 over 16. Okay, so remember, when two lines cross, in this case, they're going to cross at only one point. And this is the one point that they share. Okay, it's also important to note that if you tried to graph these two and just look and visually inspect what the answer is, you wouldn't really be able to look and come up with this. So this is one of those cases where the addition method is important and better than a graphing method.